We are now multiplying. We've added and subtracted. This is part 1 of multiplying. Today we're going to be multiplying a monomial, which is one term, by a polynomial, which can be any amount of terms. I know we talked about polynomials being 4 or more, but for our purposes today, it's 1 by anything. So it could be a 1 by 2, a 1 by 3, a 1 by 4. When we multiply the coefficients, and we add together our exponents. So we multiply the coefficients and we add together our exponents. The reason why we add together our exponents is x squared means x times x. X to the third would mean x times x times x. So if I were to multiply those together, I would have these 2x's times these 3x's. So I would add those together. 2 plus 3 would be 5. That would be x to the fifth. So that's why we add when we're multiplying. Some things that are going to help us while we are multiplying. We have invisible ones in a lot of places. If we have an x by itself, we can make that be 1x to the first power. If we have a negative x by itself, it's going to be negative 1x to the first power. Okay. Then I have this here again for us. The coefficients, the number in front, our variable is our x, and then our exponent is our exponent. It's our little degree, it's our little guy up there. So with that, we are going to get started multiplying. What we're doing today is essentially big distribution problems. When we multiply the coefficients, we add the exponents. So that's what you got to remember. Multiply the big numbers, add the little ones. So moving down to my first problem here, I've got 2x squared times 3x squared minus 5x plus 6. So the first thing that I'm going to do is I'm going to put an imaginary 1 on this 5x. I'm going to make it minus 5x to the first. Zoom into that a little bit. Okay, so as I'm going through these, I'm going to say what I'm doing to make sure that you are listening. And if you miss why I put a number where I put it, ask about it. So we are multiplying our coefficients. 2 times 3 is 6. So we're distributing essentially. And then we add our exponents. 2 plus 2 is 4. So my first term here is 6x to the fourth. Okay, my next one, I'm going to do 2 times negative 5. 2 times negative 5 is negative 10. So I multiply my coefficients. And then I add my exponents. So 2 plus 1 is 3. So that's x to the third power. I can get it later. And then 2 times 6 is 12. So 2 times 6 is 12. And then when we add our exponents, we're adding 2 to nothing. So there's no exponents here. So 2 plus 0 is just still 2. So we still have this x squared. And that right there is the thing that people forget the most, just to forget to distribute out that x squared. So when we distribute, we multiply our coefficients, we add our exponents. It's just distributing, but like you do 2 steps each time you multiply out. Any questions on that one? Okay. Then let's look at the next one. So the next one, we have negative 3x. I'm going to make that negative 3x to the first. Times x cubed. I'm going to make that 1x cubed. Minus x. I'm going to make that minus 1x to the first. And then plus 3. So I added in all sorts of imaginary ones there.
Where do you have dementia?
So then we're going to multiply these. So you've got negative 3 times 1. Negative 3 times 1 is negative 3. And then I add my little exponents. 1 plus 3 is 4. I always write in my imaginary ones, because if you don't write them in, you forget to add them. Okay. Next, we've got negative 3 times negative 1. A negative times negative is positive, so this becomes plus, and then 3 times 1 is 3. Once again, I add my exponents. 1 plus 1 is 2. So plus 3x squared. And then negative 3 times positive 3 is negative 9. And then again, I distribute out my exponents too. I've got x to the first here. I've got none here. So 1 plus none is still 1. So this is x to the first here. So each step, you are multiplying your coefficients, adding your exponents. A couple things I want to point out before we do our last couple of examples. These answers should all be in standard form because the thing inside the parentheses is in standard form. And if we're adding the same thing, so we're always adding 1, so they're just going to go up by 1, it'll still be in standard form. The other thing I want to point out, what's 1 times 3? 3. So there's 3 parts of our answer. 1 times 3, there's 3 parts of our answer. If it's a 1 times 4, there's going to be 4 parts of your answer, okay? So however many pieces are inside the parentheses, inside that long polynomial, that's how many pieces your answer will have. Hey, flip this over. We got 2 more on the back. I don't know why my camera is being so laggy today. I'm going to change the... Let me change this setting and see if that helps. This is the one I used to do. Let's try this. All right. We're going to distribute out this 5. On this one, the only thing we're distributing out is a 5. So this is just like we're multiplying everything by 5. So 5 times 3x to the 4th is 15x to the 4th. 5 times negative 3x squared. The 5 times negative 3 is negative 15. And then it's still x squared.
Which is 10.
And then the 5 times 2 is just 10. So sometimes all you're going to distribute out is a number. And if that's what you're doing, then you just multiply everything by that number. All right. The very last one, we're just multiplying everything by x. So I can put my imaginary ones in, my 1x to the first. Since all I'm multiplying by is 1, the numbers, the coefficients aren't going to change because 1 times anything is itself. The exponents, however, will change. So 1 times 2, still 2. But then I add my exponents together. 1 plus 3 is 4. So I've got 2x to the 4th. And then the next one, 1 times negative 3 is negative 3. And this x to the first also distributes out the x to the first. Just like we can add in our imaginary ones, we could also take them out. We wouldn't have to write that. You could put 2x to the 4th minus 3x, and that would be correct as well. All right, any questions right now? Okay, less than 10 minutes.